Hi guys, so this is a problem about function and relation. So U is a set composed of an integer 1 to 10, while A is also a set composed of an integer 1 to 5, B 4 to 8, and C 3, 4, 7, 9, and 10. Well, D is a set which is composed of A times B union B times A, then minus C times C. And E is a set of ordered pair x, y, which is an element of D, and x plus y equals 10 or y minus kx equals 1, where k is an integer. Well, if the number of E is 6, then find every possible value of k. Well, so the first thing I want you to do is you need to consider everything as sets. So set A times B, which is from D. So I'm gonna look everything in set, and I guess it will be easier. So the first thing you need to do is, well, you draw a graph, and I'm gonna plot the points. So, well, let's do some example. So what is the product of A times A? Well, first thing you need to know is, well, what is the number of products produced from A times A? Well, it is number of set A times number of set A, which in this case is 5 times 5 equal 25. So what is the specific ordered pair? Well, the first is, well, 1 times 1, 1 times 2, 1 times 3, and so on. So if you count, it will be 25. Right, so A times B will be something like, well, first is 1, 4, second is 1, 5, and so on. But if I write that, it will be too hard and too long. So I'm gonna try and plot the graph. So for example, here's 1, 2, 3, 4, and 5. Also this one here. So suppose, well, I'm gonna do it as A times B. So I'm gonna write 4 here, 5, 6, 7, and 8. So A times B will be something like 1, 4, which is here, 2, 4, which is here, 3, 4, 4, 4, and 5, 4, up until here. Well, I won't write it all, but I suppose you get the idea. And B times A in turn will be like 4, 1, 4, 2, something like. So suppose this is 4, 1, 4, 2 will be something here, 4, 3, and 4, 4. So this is 4, 4. So there will be some intersection area between A and B, which in this case, you can see here, there are two numbers which are in B as well as in A. So it is 4, 4, and 5, 5. So the ordered pair that can be found in both A and B are 4, 4, 4, 5, 5, 4, and 5, 5. So the number of A times B union B times A, once B, well, number of set A is 5, number of set B is also 5. Well, and the number of set B here is 5, and A is 5. So when you union this set with this set, you might think that, well, so the total elements of set is, well, 25 plus 25, which is 50. But in this case, if you think like that, then you're wrong, because there are some intersection areas that I just told you, and there are 4. So you need to minus that with 4, and the total number of the elements here will be 46. Because, well, for example, if set anything, set C is 2, 2. So how many number of elements are in this set? Well, you might guess it is 2, isn't it? But in fact, well, 2 is equal and similar to this 2. So the easiest way and simplest way is to write it as 2. And the number of elements here is 1. Same in this case, there will be some ordered pairs that can be found in both A and B. So in this case, you need to minus 4, which is the number of elements here. So I think you get the idea. And C times C. Well, you might think that, well, we need to write every possible case, but in fact, you may not need to. So, for example, if I had any sets, for example, given that this is set, well, set M, and M is equal to 1, 2, and 3. And another set is set N, which is 1, 2, 3, and 4. And if I ask you, what will I get if I write M minus N? Well, so what you need to do here is, well, you know that you get nothing because it is 0, or an empty set in terms of set. Because here, 1 can be found in M and N. 2 can also be found in M as well as in N, and 3 also. But what about 4? In this case, if M is smaller than N, and I ask you what M minus N is. So suppose this is set M and this is set N. So N is bigger than M because 4 is in here. But if I ask you what M minus N is, you don't need to care about that area here. So the only area you need to care is an area which is an intersection between M and N, which in this case is all the same. So the result is 0. But if I ask you what N minus M is, well, right now you need to consider a 4 because this is M and this is N. And M minus N. So what is left is the area here, which is 4. But in this case, it is A times B union B times A minus C times C. Well, you know that the highest possible value of the set here is 8. So when a set which is consistent of 8 minus something, well, you know that if any value that is greater than 8, well, you don't need to think or care about it. So in this case, I will not care about 9 as well as 10. So C times C, I will only think about 3, 4, 7 times 3, 4, 7. And, well, the results are 3, 3, which is here, 3, 4, 3, 7. So I'm just going to write it. And then 4, 3, 4, 4, and 4, 7. And the last thing, 7, 3, 7, 4, and 7, 7. Which in this case, well, all of which are in this set. So the number of elements in D are 46, which is here, then minus 9 here. Because every ordered pair in this set is in this set. So there are some similar ordered pairs in these two groups, so you need to minus them. So the result is 37. So number of elements in D is 37. Let's look at D. So D is any x, y ordered pairs which are in D, and x plus y equals n, or y minus kx equals 1. So if it is correct if it is true in one case, then it is fine. So because the sign here is union. So what we're gonna do next is deal with the set E. So x plus y equals 10 or y minus kx equals 1. Find every possible value of k. So what you need to do is you need to try k. The first thing is, well, suppose k equals 0. Well, I forgot to tell you that, well, k is an integer which is greater or equals to 0. So if k is equal to 0, then y minus 0 equals 1 or y equals 1, which in this case are 4, 1, 5, 1, 6, 1, 7, 1, and 8, 1. And another case is x plus y equals 10. So another pair is, well, 2, 8, 4, 6, 5, 5, 6, 4, and 8, 2. So you guys may be wondering, where was 3 and 7? Well, 3 and 7 are here, which I just deleted it, so it won't be in the sets. So total elements of this one are 10. But I ask you possible value which gives NE equals to 6. So this case is wrong. Next step is, what if k equals 1? So if k equals 1, y minus x equals 1. And another same condition, x plus y equals 10. So we already know that x plus y equals 10 can only happen in 5 cases, which are the following. So in this case, n equals 5. So suppose k equals 1 and y minus x equals 1, 2. So the only possible answers are 4, 5, and 5, 6, because others that aren't 4, 5, and 5, 6 aren't in the sets. And, well, this group and this group, there aren't any pair or pairs that are similar. So the whole number is 7, which is still wrong. The third case here is when k equals 2. What you'll have is still the same. X plus y equals 10. And number of elements is 5. And here y minus 2x equals 1. In this case, the only possible one is 2, 5. Well, you might guess, how about 3 and 7? Because 7 minus 2 times 3 also equals 1. But as I told you before, 3 and 7 are in this case, and I already removed it, so it won't be found here. So if you try something else, like 4 and 9, well, you know that 9 is not in the sets because the highest possible value of B here is 8. So there is only one case possible, which is, well, where is it? Which is 2, 5. So total elements of this case is 6, which is what exactly the problem asks. But is it the end, or Are there any values that satisfy this? Well, let's try another one. So if k equals 3, y minus 3x equals 1, and the same condition here, x plus y equals 10. So as I told you before, n equals 5. So in this case, possible values are 1, 4, 2, 7. So are there anything else? What if 3? So if it's 3, then y must equal to 10. But 10 is not in the set, so this is wrong. So these two satisfy the equation above, well, the set above. So the number here is 2. So the whole number is 7. So next is when you try k as 4. Y minus 4x equals 1 and, sorry, x plus y equals 10. So this n equals 5 once again, and in this case, 1, 5 works very well. And, well, how about 2, 9? Well, 9 is not in the case, so we can't use it. So here, the whole number is 6. So the possible values are when k equals 4 and k equals 2. But how about if k equals 5? Note that, well, the possible cases will narrow and narrow down until we can't find any. So in this case, well, I'm just gonna try this one because we all know that x plus y equals 10. There are 5 cases from this. So here, if x equals 1, y equals 6. And the pattern I want you to know next is, well, if k increases and we increase x by 1, for example, if x equals 2, the y will greatly increase to 11. So this is not possible again because 11 is much greater than 8. So please note that this pattern will continue until we reach the maximum, which is 1 and 8. So 1 and 8 will happen when k equals 7, because the equation will be y minus 7x equals 1, and we substitute y as 8 and 7 as 1, correct? So possible values of k are 2, 4, 5, 6, and 7. So there are only 5 possible values of k. So if we continue from here, for example, 1 and 9, well, 9 is not in the set, so this is not correct. So I guess that's all for this video. It's a bit too long, but I hope you like it. So if you have any comments or you are confused about anything, please leave in the comments below and I'll try to answer as soon as possible. Thank you and goodbye.